Yeah, I'm ready anytime.
All right, we are recording.
So got it. All right.
So should I do an intro? Maybe I should. I already forgot how things work now.
Well, I have a bio.
Yeah, I do.
I mean, I have a very short bio in my talk, so I can just introduce myself.
Oh yeah, you want to do that? Yeah, go ahead, Dennis.
Yeah,
I mean, I was going to read your bio. That was I don't know.
It's okay. And
okay.
I'll just touch upon it. So, all right. Well, thanks everyone for coming. Really appreciate it. And again, I apologize that this talk is not highly resonant with Wasp or cybersecurity, but I've given talks before for the group, and they've been pretty well received, even though a bit off topic. But AI certainly has, you know, a lot of cybersecurity applications run using AI, like email, like spam detectors, right? They use pattern recognition and so forth. So it's, you know, it's not irrelevant, and it's becoming pervasive in our daily world. So let me call up some charts. Oh, I guess I need to share my screen. So I will do that. And yeah, post any questions, just put them in chat, and it's okay to interrupt me. Let's do this. All right. I spent half the day yesterday cleaning up my Chrome tabs, so it didn't look like I had 500 things I was doing at once, which it normally does. So let me get this thing out of the way. Okay. It's really hard to do this with all this thing in here. There it is. Let me go to the top of this thing. Oh, I did. Okay.
Yeah, we can see it now.
Okay, great. So it's my little talk on using machine learning to play a biased coin flip game. And I'm studying AWS cloud computing at El Camino. Actually, I finished, got my little 2-year degree. And then I took a course last semester at Santa Monica College on machine learning using AWS, Amazon Web Services. So let's see. How do I? Here we are. So here's the agenda, bio, and charts and demos, and charts and demos, and so forth. So my name's Dennis Kane. I grew up in New York State, upstate. I have a master's in physics from UCLA. I got to work at CERN for 3 months. You know, high energy particle physics. That was fun. A very long time ago. We were finding first evidence of the proton, probably. So it's a joke. So I worked at Hughes Aircraft for 31 years in real-time radar control, the software engineer, and various levels of management. I've been spending the last number of years teaching and tutoring in physics using spreadsheets, project management, and Python. I've also been studying cloud computing at El Camino and Santa Monica colleges. I actually ended up being the El Camino official AWS Educate student ambassador, probably because I'm the only person that applied for the job. So I didn't get paid for it, but it was nice. It didn't get a t-shirt, but I was hoping to. I got some other perks. It was fun. There's my email, dennisjkane@gmail. It's one of my 12 emails, I think. And my LinkedIn page. Actually, if you go to dennisjkane.com, I think it takes you to the LinkedIn page. So everything I'm showing you today it's available for your downloading. You can move it to it's all on Google Drive. You can move it to your Google Drive. There's a repository, which is a Google Drive folder that has everything in it. I put the link on the right just in case somebody prints these or does, and I didn't use embedded links. So, but you know, there's the link to it on the right. I think I just set up a forwarding. So if you go to coin, COIN .dennisjkane.com, that might work by now. It'll take you to the folder. That should be easy to remember, I guess. Otherwise, you can click on that copy that thing on the right somehow. Get your phone and take a picture of it. So what's in there? A bunch of slides, like these slides, a write-up. So there's like an article. Might be a good place to start because it gives a narrative of everything that I'm talking about today, and all the supporting files that support this talk. So. All right, so just quick graphic on what's AI versus machine learning versus deep learning, neural nets, and all that. So artificial intelligence, because it all gets conflated, with all the terminology. So, but artificial intelligence has been going on forever. It's just using a computer and trying to make it be able to do decisions like a human does, right? So playing games, playing chess, and so on and so forth. It doesn't necessarily use neural nets or deep learning or machine learning or any of that stuff. You could use what they call classic programming nowadays, I guess, which basically is a bunch of if then else's for decision making. Right? So that's in general, but a subset of that is machine learning, and that's where your application actually, through experience, improves itself, and it does a better job of AI. So it's a general category. Another level below that. So there's neural nets and deep learning, and that's where it's actually using very specific algorithms that mimic the functioning of the brain, human brain, well, any mammal, I guess, and to do machine learning. Okay, so there's a great video or movie, because it's a movie, a documentary that I recommend. I don't know what it's called. I'm sure someone in the audience knows, but it's about how Google, what was their application,
Oh, the AlphaGo?
Yeah, so AlphaGo. So there's a documentary about how they used AlphaGo, the specific hardware, which I think they use tensor processing units. So not GPUs, they use tensor processing. So a tensor is like a matrix, a multi-dimensional, not more than two-dimension matrix, if you remember your linear algebra. So that movie's great, and it tells how they built AlphaGo, or whatever they called it, to beat the world champion Go player. And the way it did it is, I don't know, it played itself 1,000,000 times in 45 minutes or something, and that's how it got from novice to world class. And so it's really neat. And there's some articles about that too, various things. So if you ever want to that's the thing that inspired me to look at this more closely, because I was playing with artificial intelligence, I don't know when, probably the early 90s. And I was not that terribly impressed. I knew they were basically, they were just starting to get to the point where they could compete at world-class level with chess, and how they solved it. It was basically a brute force method. They just search all the possibilities, and they scored them each one, and that's how they did it. So, and if you watched, there was the competition. When was that? I think that was probably mid-90s, where they beat the world chess Kasparov. It was a Kasparov, I guess. They beat Kasparov, probably.
I think it's in two. I don't think it's in the night. I think I heard like a robot or whatever you call it beat the chess player. I don't think it was that many years ago. Was it?
Yeah, I'm pretty sure it was in the mid-90s.
Well,
I'm not.
okay.
I'm pretty sure. I'm not, because I remember watching it on my DSL, and my Performa Macintosh computer. So it might have been the late 90s, early 2000s, possibly. We can go look it up.
Okay.
Yeah, there's an assignment for someone in the audience. Go see when Gary Kasparov got beat by a computer. Now the world class, the world champion is a computer, hands down. There's no human that can beat. And just whatever it was 5-6 years ago is when the world, they figured out Go. So anyway, I'm sorry, I got sidetracked. So I looked in the 90s. I was interested that they could play chess well, but wasn't terribly impressed that I didn't see how it would eventually be pervasive. although I did hear about neural nets back then, and that's when they were just starting out. And then of course now we have what we have, which is it's inevitable that they'll be our they'll be our masters someday. Anyway, that's the difference among the three different terms. And why can't I advance? There we go. So here's the problem statement. So how the question, I was wondering about machine learning. Can I do something really on the surface simple that I can analyze well on my own and then see how well a computer does it? And so I decided for whatever reason that I wanted to do a coin toss game. And I wanted to see how well a bias coin toss, and I'll tell you what the bias is in a minute, how well a machine could learn how to play that game. It's kind of like rock, paper, scissors. So the question is, well, what if, how is it biased? Well, what if it's altered conditionally to vary in a consistent way? So here's how it's biased. So typically a coin toss is 50-50. So what if you have it that on the instances where you get two in a row, then all of a sudden the probability changes, and that the third toss could have a bias. It could be either more likely to get the same as the previous two, so like 3 in a row would be likely, or you could have it less likely too. And for whatever reason, I sort of centered on 70%. So got 50-50, I toss the coin again, it's still 50-50, but then if it gets the same as the previous toss, then the third toss will be 70-30, let's say. And that keeps going on and on. So, and you do get 3 in a row. So then the fourth one would be 70-30. You'll keep doing that until it breaks the sequence, and then it goes back to 50-50, right? So it's pretty obvious if you know that algorithm and you know that's what the coin did, what you should do if you're playing this game. Any toss, typically it doesn't matter, it's 50-50. But as soon as you see 2 in a row, you should guess the same as the previous two, because you got a 70-30 chance of getting the right guess, and then you keep doing it. So real easy for a human to understand once they know the rules, but can a computer figure that out if you just give it a bunch of data and you don't, put that into the program? So that was my problem statement. So to do this, I used Monte Carlo simulation. I first learned about Monte Carlo simulation, I guess undergrad school, many decades ago. But I think it was a summer program where we wrote we were writing a Fortran program to let's see, simulate someone getting X-ray, is it gamma, right? It was X-ray treatment. I think it was X-ray. Might have been gamma. Oh no, it was or might have been neutron. I can't remember. There's some sort of radiation treatment of tumors, and was to be able to predict, what type of where most of the energy would be deposited. So what is a Monte Carlo simulation? And hopefully there's somebody in the audience that doesn't know what it is, and this will help them. So what it does, it uses randomness, or random number generators if you're using a computer, to do calculations that might be too hard to do in a closed form. So here's an example of that on the right here. So you got this funny squiggle. And if you were asked, well, what's the area of that thing, right? Then I guess you could chop it up into pieces, right? And, put it on a computer and try to draw the boundaries, which would be kind of hard because it's a weird shape. Or what you could do is you could take that shape in the square and put it up on your wall and throw darts at it. You could throw like 10 darts or 100 darts. Oh, you have to throw the darts, you have to close your eyes, right? So you don't know where the darts are going. And you just sort of throw it toward the wall. So some of the darts will hit within the weird shape and some don't. And if you know the area of the big square, then all you have to do is count the number of darts that landed within the shape and versus those that landed outside the shape, and you do the ratio with the total area of the square, which is very easy to calculate. And then you can figure out the area of the squiggle. So that's an example. That's not a computer doing it. That's you and some darts. And there's videos of people doing this on YouTube, of course, because everything's on YouTube, right? So it's using the randomness of throwing the darts to do a very hard calculation, which is the area of that squiggle. And the reason it's called Monte Carlo is got nothing to do with Monty Python. It's got nothing to do with Monty Hall. Monte Carlo is a city in Europe somewhere where it's like Las Vegas, right? It's a gambling city or island or whatever it is. And they have casinos there, and they use gambling to make money. And
Wasn't that also the half car, half truck? Is that a Monte Carlo?
half car? Oh yeah, that was like a Ranchero. Yeah, they had a a Monte Carlo, I think, was a really big like sedan, like a Buick or
Oh,
something.
maybe.
Yeah,
what's
no,
now? I gotta look up the half car, half truck thing.
yeah, that's like a ranch. I remember Ranchero, but there's another thing. It's another version. And
I
but
knew it
yeah,
was a
no, I
car
think,
though. It had
yeah,
wheels.
so it was a very big luxury car. So anyway, so do you know, Dante, whether my audio will play for the audience if I click on this movie?
I think it depends on how you have your sound set up, but possibly.
One
I
would
mean,
think
I know
so.
that it can.
Well, let me try it, and if it does, it does, and if it doesn't, it doesn't. And okay, all right. So let me.
Mr. Brown here. I got a quick brain teaser for you.
All right, is the audio coming through?
Yeah, I can hear it.
Well, if you can hear it, I'm sure everyone can. So.
I can.
Yeah, we can hear it.
All right, here we go.
If I'm down 3 with 30 seconds left, is it better to take the 3, or is it easier to take the 2 and attempt to foul a bad free throw shooter and get another possession? Here's my friend Sal with the answer.
That's a very, very interesting question, LeBron. Calculating the probabilities of if you were to take a 3, what's their probability of tying the game? And
so I'm not going to play the rest of that. I just enjoy hearing LeBron do an introduction to math the way he did it. And actually, now that I've heard it 2 or 3 times, I actually now I know what he's saying. I had to think of it because I'm not a basketball expert, but the point is, you can take a sort of complicated problem like that, or the one I mentioned with the simulating an X-ray treatment machine for cancer, and program it up in a computer and do this simulation using randomness and lots of decision logic and so forth, and you can do calculations of stuff you can't do in a closed formula, like whether LeBron should take the 3 or go for the 2 with the foul. Right? So, I guess it matters how much time is left. So hopefully now you know what a Monte Carlo simulation is. So I guess I should have put so in that folder I mentioned, the coin.dennisjkane.com. Hopefully the forward is working by now. There's an article that gives a nice narrative of everything, and then it points to all the other files in the document. So this is one of the files it points to, and there's a spreadsheet that does a Monte Carlo calculation, and it's got several tabs, but the first one is just it does like 10,000 throws of a coin, and it uses, so there's 10,000 throws of a coin, or it flips, and it has the yellow. I use this convention where any variable I want to alter to change how the spreadsheet is working, I just give it a color. So this one uses a bias of this example, 0.7. So again, it flips it once, 50-50, flips it again, 50-50. But if it got the same 2 in a row, the third time, it'll be more likely to get the third 3 in a row. In this case, 0.7, right? So here, here's an example, and hey, you can't really see the 0.7 in here, but the fact that you see a lot of reds here tells you that once you get 2 in a row, it's very likely to get 3 in a row and 4 in a row and so forth. And you can change this from 0.5, which basically that's normal, to 0.7, 0.8, or whatever. You got to wait a little bit because it's a spreadsheet, but then it does all the 10,000 flips. And this is in a Google sheet, and it's in that repository I mentioned. And there's other tabs in here, which we'll talk about later. And by the way, here's the link to the spreadsheet. So, oh, yeah, okay. I always forget that I have these cute little animations, but I already talked about that stuff. So I didn't talk about this, the red circle or ellipse or whatever it is. That's so you can do a calculation. You can say, well, for a bias of 0.7. And by the way, have I made clear what the bias is, what it means algorithmically?
Is the bias derived from you can manipulate this yourself manually, or that's just the outcome from the flips?
No, you can manipulate this self on your own. So you can say, well, if I toss 2 in a row, my chances of getting a third one, I'm just going to say 0.7. It's just a funny coin that knows the last 2 flips, right? Or you could say 0.8. You can say 1, and then as soon as you get 2 in a row, then it'll always it'll never change, right?
So basically the bias is whatever you want to like screw with it. Like however you want to input stuff with.
Yeah, so it's the weirdness of your coin.
So you're
So
manipulating the probability, adjusting the bias.
That's right.
Okay.
Oh,
And,
I see. Okay.
So the average streak basically is, well, okay, on the average, how many you're going to get in a row? If you do it 10,000 times, on the average, how many are you going to get in a row? So like here we go. First throw, I got 1 in a row. Second one's different. I got 1 in a row. Okay. Now, I still got 1 in a row. It's different, but then it's, oh, I got 2 in a row. So I'll put a 2 here. Oh, I got 3 in a row, a 3 here, 4 in a row, 4. And
So is red are we saying tails, or doesn't it really matter?
Yeah, red
Green
is tails.
okay.
Yeah, red -1, tails. Thank you for pointing that out. I've looked at this thing so many times I forget my convention. And green 1 is heads, right? I should have put H and T, but it's easy to do the calculations if they're numbers, right? So I got 10 in a row. I was like, ooh, but then it broke the sequence, so we're back down to 1 in a row. 1 in a row. Oh, I got 2 in a row, and so on. So you get the idea. So I can use this spreadsheet to answer this question. On the average, how many do you get in a row, right? And this is actually easy enough to figure out in closed formula, which I will show you. And I did get it right. I got it wrong the first time. First time I did the calculation, I got the right answer by accident because I had a 2 up here, another factor of 2 up here, another factor of 2 in the denominator, and they canceled. So I got the right answer by accident. But this is the right answer. But anyway, so on the average, if you, I shouldn't even show you that. Okay, so maybe you'll forget because I forgot. Okay, so what is the average streak? So for unbiased, it's always 50-50. Right, so okay, so let's say you have an unbiased coin and you toss it, right? So sometimes you get heads, sometimes you get tails. Getting 2 in a row doesn't change anything. This is a completely unbiased coin. So just taking a poll, whoever wants to answer, what do you think the average streak is? Like on the average, how many do you get in a row? If it's 50-50. So if you get tails, yeah, you get heads, 1 in a row, tails, 1 in a row. You get tails. Oh, I just got 2 in a row, so put a 2 down. Get another tail. Oh, 3 in a row. Heads. Oh, back to 1. So on the average, how many do you think you'll get in a row? If you throw it like 10,000 times.
Oh.
You can use a gut feeling. You don't have to do any calculations if you don't want to. You think on the average, is it 1 in a row?
I'm
Or
gonna
do you
say
think-
2.
Okay. Is that Vincent or who was that?
Oh no, that was Dante.
Oh, okay. 2. Dante says 2. Anyone else?
I'm gonna go with 2.
All right. By the way, just to do a little bit of a calculation, what's the smallest this number could possibly be?
One.
You said it goes up to 1,000, right?
Yeah, 1. Right. So
One.
yeah, because the smallest you could ever get on the average, well, ever, is 1 in a row, right?
Right.
But you could get 2 in a row. You could get 3 in a row. You could
Get
get 8 in a
10,000
row.
in a row. You
Right.
did.
So Dante, does that make you want to change your answer to something more than 2?
I don't know. My brain is still even questioning would the bias even matter? Would almost
This-
like a
Yeah, in this
Schrodinger
case, there's
cat,
no
like-
bias, right? There's no
No,
bias.
no, yeah, but even I'm just thinking, the bias though is the bias actually changing the outcome, or it's just changing the prediction? Because if it's just the prediction, then I almost think that it doesn't really matter. It will always be whatever it will always
Right,
be.
so it changes both, right? If you do have a bias, if you do have a, which we don't in this example.
Right, right.
But if you did have a bias, if you got 2 in a row, you'd be, assuming the bias was greater than, 0.5,
0.5, right.
you,
right.
you'd want to guess the same as the previous 2 throws. If it's less than 0.5, you want to guess the opposite.
So I guess with a 50-50, then maybe I changed my answer to 1.
1. Now, again, a good
Why
way
do
to
you
do.
decrease it, Dante? I don't understand. I thought if
Well,
it's
because
longer, it
okay,
should be-
because if it's 50-50,
I
Uh-huh.
think you're just playing mind games. I think I'm sticking with 2.
well,
Think
it's
of it this way. Think of it this way. Think of it this way. A good way to do these calculations sometimes, if you don't want to do the math and you don't want to write a computer program, bound it, right? Just think of what's the smallest it could be. So that we've already determined that's 1, right?
Yep.
And what's the biggest it could be? Well, infinity, right? You could have a coin and you could just be really lucky, even though it's 50, or maybe unlucky if you don't, and you could throw 1,000 heads in a row, right?
right.
So the bounds is 1 to infinity, right?
Yeah.
So what's the average?
So you just cut infinity in half.
Hmm.
And then
Okay, we're gonna ask Vincent. He's the guy who's what is the title? Your job title? Data. Whatever.
Okay, what was the
Statistics.
question? All right, so the sample space should be like 0 to infinity. And so I think he's asking for the expected value, right? Right, Dennis?
yeah,
Yeah.
Mm-hmm.
Oh, geez, don't ask me. Off the top of my head. So 50-50, and then what was it 70% chance every time? Oh, 80.
so yeah, it could be 70-30, it could be 20-80. Oh, 20-80 means that it's less likely. So what happens if it's like you get heads? Now, what's the third one going to be? Well, it's 20% that it's heads again. So it's less likely that you get 3 in a row. So you could do all these questions, right? And you could answer these questions by either writing up a Monte Carlo, but we use this spreadsheet I did, or you can come up with a closed formula. So that's the closed formula, and that's right. I'm sure that's right because I like I said, I had to redo it twice because I got a factor of 2 in the top and bottom that cancel. But it's 2 minus 2.5 times that bias, whether it's in this case it's 70%, in this case it's 20%, right? Plus the bias squared divided by 1.5 and so on. So that's the closed formula to answer the question, what's the average streak? And here it is. So whoever said 2,
Oh, see, that was my
0.5,
gut. That was
it was, I think Dante, you did until I tried to do a mind
yeah.
game with you.
Yeah,
And
called
then,
it.
and then somebody else said, "Oh no, he's doing a Jedi mind trick. Don't listen to him. It is the droid you want." And so yeah, it is 2 in a row. I see. I would have gut feeling. I would have thought it'd be higher. So it's exactly 2 in a row. Probably somebody with a binary search or something. But anyway, for 0.7, it's 3.08. For 0.2, now you're biased in not getting 3 in a row, right? It's 1.48 is the average. So it's less than 2, which I guess you'd expect, right? So, and that's from the closed formula. Okay. And I got on that article I mentioned, the derivations in the article, but what it uses, and this should take you back to middle school. So in addition to getting your pigtails dipped in ink or whatever happened to you in middle, or something worse, getting a wedgie, I guess would be in middle school. So this is the beginning of the formula. It's about 2 to 3 times this long, but this, I'm not going to run you through the derivation, but basically you figure out the odds of getting 1 in a row and 2 in a row and 3 in a row and so on and so forth. And so it's, the probability times actually getting that. And then normalized, you divide by adding up all those probabilities. And that would be the average streak. And so this gives you this derivation, and you have to, this does the denominator for the fraction. You have similar stuff for the formula. Well, what it uses, I don't know if you remember this, but when you were in grammar school, if you got, or no, it was middle school, and they asked you, well, the decimal, like 0 or 1.325 repeating, what is that in fraction form? So like 1.325, 325, 325, 325, right? So does everyone remember how to change that into a rational, like a fraction?
Sorry, is that again?
So if you have a repeating decimal, like 0.37373737 forever, does everyone remember the trick to?
Oh, I think you set it equal to X, and then you multiply like both sides by a number like 10, and then
Yeah, so you multiply, right? So you
Yeah.
multiply by a power of 10. So like, let's say it's 0.3737373737. Then you multiply, you take that equal to X, then you multiply it by, in that case, 100, because it repeats after 2 decimals, right? 373737. So that's the 10 to the second. So multiply by 100. So now you got 100x equals 37.37373737. And you've got 1x equaling 0.37373737. So you take the difference, right? And that would be 36x equals 37, right? Something like that. So it's like 36/37, I guess, something like that. I don't know. It's hard to do algebra in your head, but
it's in the
so
chat.
anyway, that's the trick.
Chat.
Oh, yeah, if you look in the chat, he's got the.
Oh, cool. Yeah, so it's called geometric series, and so on and so forth. So I'm sorry again, but it doesn't hurt to do a little bit of middle school algebra. I don't know how
It does. It does hurt. It hurts
It
a lot.
does hurt. I used to be really good at math.
Oh,
and
there you go.
What
I
happened?
don't know.
See, I did it in my head, and I said 36/37 or whatever, but that's wrong. It's 99. So it's 37/99. Thank you, Vincent. Yes. So
You're welcome.
lesson is don't do algebra in your head because you'll make a mistake. So oddly enough, I wonder how do I go up?
And,
I
and
know.
and just for review here for these formulas, these are just out there in the ether that are known formulas, or this is a formula that you conjectured because of your experience with the bot or the flipping, or where did these come from?
Yeah, so I came from my brain. I don't think I Googled this formula, which is probably why I got it wrong the first time by a factor of 2. I derived this formula wherever it is. It's on the previous chart. There, I derived that formula, and you're welcome to check me. But I already checked myself by running a Monte Carlo, and the Monte Carlo agrees with this formula. So I'm pretty sure that's correct. If you look back at the spreadsheet, wherever, I don't know, yeah, okay. So it's right here. It says the average is streak is 3.12. That's calculated using Monte Carlo, and using the closed formula, I get 3.0832, and so on. And I've checked other values, and it's close enough where I say, yeah, I probably got the algebra right, or whatever it is. All right, so I gotta go back here. But geometric series and all that, it's all very standard. It's the same thing that you use to compound interest and all that. Oh, and then I further checked my math by my reduction of the infinite series by another spreadsheet in here, and it converged pretty quickly. So using this method, I also got those. So 2 different. This isn't Monte Carlo. This is just plain old calculating an infinite series kind of thing. So just term after term. And that's also in the spreadsheet. And I got the same answer. I got 308. from after 150 series, basically it's the same dang thing. So I'm pretty confident in my ability to do middle school algebra here. At this point, I apologize. So I should apologize to Python enthusiasts or any other legitimate programming language because I'm using spreadsheets so much. But in fact, if I was a self-respecting software engineer, I would have used Python to do all this or a Jupyter notebook, but I don't know. It's so easy for me to do things in a spreadsheet, even Monte Carlo calculations. I just tend to go that, but I probably, to be more respectful, I should go to Python nowadays. So I apologize. So what's the perfect strategy? I think we already discussed it. Basically, if you have this bias coin toss, you wait till you get 2 in a row. And once you do, then you would guess the next one. So there, here's some examples. I'm not sure. Oh, yeah, there's a little bit of a mismatch here. I got to look at my formulas. But basically, you wouldn't bother guessing when you don't get 2 in a row. But, okay, I see why I'm having trouble. So this looks back at another spreadsheet. But anyway, you wouldn't bother guessing. And then whenever you did get 2 in a row, you would guess, right? So you'd say, oh, I should get 70% right because that's what my bias is, right? Well, that's kind of cheating, but it's cheating unfairly. And I think it's more clear now if I do this. So if these are your tosses, right? If it's a machine that supposedly does not know the algorithm, right? It's got to make a guess every time. It doesn't have the luxury of not guessing when it doesn't get 2 in a row. So you should guess 2, and you should make a guess every time. It's just when you have an advantage when there's 2 in a row. So you get a heads. So you just randomly guessing here. But ooh, now you got 2 heads in a row. So you should guess heads. And this time it was wrong though, because it came up tails. There's still a 30% chance in this example of being wrong. But then it got heads. Oh, got 2 heads in a row. I should guess heads. Oh, it got wrong again. So a little bit unlucky. But if you kept going down and did this forever, which I did, you should get a number, better than 50-50. So what should you get? So this is cheating fairly. So half the time you're guessing incorrectly. I'm sorry, you're guessing randomly because you don't get 2 in a row. So what's the calculation? So I'm going to preface this by saying this is wrong. So this is where Vincent can help. So let me go through this really quickly. So one toss happens, you just guess randomly, you don't care, that's 50-50. Another one happens, that's 50-50, doesn't matter. But now that 2 tosses have occurred, one of 2 things has happened. Either they're both the same or they're both different, right? Or they're different, right? So if they're both the same, on the third one, you should guess the bias, 3 in a row, right? Assuming it's 70%, more than 50%. And if they're not the same, then it doesn't matter what you guess. So there's 2 choices, right? So the first throw, you don't care. The second throw, you're either going to get the same or different. And if they're the same, then you should guess the bias. So half the time, so my logic was half the time they're going to be the same. So on those, you guess the bias. So this calculation will show you what's the chances of this shows you what's the chances of getting the third toss right. And then that happens half the time, right? And then the other half the time they're different. So then it's 50-50. So you add these 2 together and you normalize it. Well, you have to normalize it because it's 1. And so I was claiming that's the formula if you're cheating and you know the algorithm, right? So here's the funny thing. So then I did a Monte Carlo of that, and it consistently would get lower than the Monte Carlo. It's 63% here, and the formula says exactly 60%. This is for a 70% bias. So you put 70% in here, you get 60. So, okay, great. So, well, maybe it's the spreadsheet and the rounding error that's the random number generator. So then I ran it. I'm going to cut to the chase, but I also ran it in the AWS. where it used machine learning it didn't know the algorithm beforehand, but it used machine learning to figure out how to cheat, right? Well, it's not cheating, it's just making an intelligent guess. It also got higher than 60%. It got like 65%. And this was very consistent. So I said, well, wait a minute. Then I realized as recent as today, and I'd done this originally, I don't know when, a month, not quite a month ago, 3 weeks ago, that, and this is where Vincent can come in, that this formula is wrong because it's not half the time that you're going to get 2 in a row. It's more likely than that you will get 2 in a row, because if you think back one further one, if there were 2 in a row, like a previous history, then you're more likely to get 3 in a row, and then it'd be 2 in a row more likely. And so you have to do another infinite series calculation, which I didn't feel like doing. So you can verify that if you do the Monte Carlo, you'll actually get better than this formula would tell you. So the formula is wrong, I'm pretty confident. And I have to do another infinite series to get the right calculation of what on the average, what's your success going to be? And it should be greater than 60%. But I haven't done that calculation yet. So there's something for Vincent to do in the. Because you have to figure out all the other.
This is familiar. There's several branches of.
Yeah, it's like a binary search with all the branches, I guess. Yeah, like a binomial binary.
So
binomial.
does the 60% represent getting 2 in a row?
This calculation is, what if you're the perfect guesser, right? So I mean, perfect as in, the algorithm, right? You know that it's 70% bias, and you guess accordingly on the typically how much money you're going to make, right? And I thought this was the calculation, and I would get, a 60%. I'd be right 60% of the time.
If the bias was 70%.
If the bias was 70%. Well, the answer is no. That's go back to middle school. Actually, this is probably more sophisticated than this. This is like whatever upper high school algebra, and it's the number's higher, and I have to go back and calculate that.
That reminds me of Anchorman. What does he say? Like 60% of the time, it works every time.
So I got to go back. I'm not going to do it during this talk because it would be embarrassing and stumble through it, but I'll go back and figure it out eventually.
So, but the actual generator, though, how I feel like what's determining the flip? What algorithm is?
I mean, whether it's heads or tails?
Yeah.
Oh, well, I can show you that. It's if I click on this, hey, let's see if this clicky stuff works. So it's taking me to the spreadsheet, and here is there we go. Okay, so this is the Monte Carlo of 10,000 coin flips, and so this number is just a flip number 1, flip number 2. So that formula makes it so it's in this case, an 80-20 chance that you're going to have a -1 or a 1. It uses a random number generator, right? And it says basically it generates a random number between 0 and 1. And it says if it's less than the bias, pick one value. And if it's greater than the bias, pick another value, right? And so this is my Monte Carlo formula right here. And then to check it, like here's the average heads and tails. If I make this 0.5, so it's 50-50, so it's unbiased.
Yeah, I feel like I would expect like an algorithm just to be like heads, tails, heads, tails, heads, tails.
Oh yeah, no, that would be a really biased algorithm. So that there's no randomness to it. That would just be a
right.
Yeah. So this is sometimes you will get some in a row and sometimes you won't. And so the average, since this is 50-50, it's saying the average, if heads is a 1 and tails a -1, if you add this whole column, it should be 0, typically.
Right.
but it's not, it's for 10,000 flips. You add it up, it's 0.001. So the fact that this is close to zero makes me think that, my random number generator is pretty good, right? Oh, you can see how long it takes to, I don't know if you can see this animation over here on the right, it's gone now, but that just shows you how long it takes to calculate in a spreadsheet, where if this was a Python program, it would happen.
And is this actually, are there 10,000 rows?
Yeah, there's 10,000 rows. I'm afraid to move the scroll bar down.
Yeah.
Take my word for
Trust
it. I'm afraid that, who knows what could happen. But yeah, it is 10,000 rows and it does 10,000 flips. And so that complicated formula, which I don't want to take through this, because when I write code, it's like write only. So when I write it down, I work, oh yeah, it works. And then if I come back a few days later, I have to like work through it again. But trust me, this formula works. It takes care of the edge conditions. It provides, in this case, a bias for the third throw, whatever bias you put in here. So like if I could pick the 0.8, I can even put a 0.88. I could put a repeating decimal. I can't put a repeating decimal in here. It's a digital computer. But anyway, the green bar on the right tells you how much longer it takes to calculate and so forth. So, all right. Hopefully that answered your question. Let me get back to the charts. Let's see. A bunch of stuff in the way. I lost my full screen thing. Oh, what if I click on the screen dot? Oh, that helped. Anyway, so this formula is wrong. It's actually greater, because you got to consider the other times in a row and so forth. But this was a good attempt by me anyway. So we'll figure that out later, but it's close, somewhat close. So how do I prepare the data for machine learning, right? And I was going to use AWS. And in fact, I think I have it running in the background. I'll show you that in a minute. So this is a series. If I look at this, this is a series of coin toss, or I'm sorry, a sequence of coin toss. It's a linear sequence. So what you'd normally use would be AI techniques called recurrent neural networks, or long short-term memory, something. But anyway, it's basically it would analyze a whole sequence and then be able to come up with guesses, right? But I didn't quite know how to do that, so I figured, well, I'm going to cheat again. So what I did was I used something called, so instead of using an RNN to predict a binary sequence, I'm going to use something called binary classification for a problem for 14 facets. So what does that mean? It means that if you think about this coin toss of 10,000 times in a row, here's the first 15 tosses, and then the next row is the next 15 tosses. So I built this other spreadsheet from the first one that chops it up into sequences of 15 throws, right? So then I said, okay, let's turn this into a classification problem, and said, okay, for what's the 15th throw for all these 14 tosses, right? And then here it is again, here it is again. So how do I do this? So let's say it's an AI program that tries to calculate whether or not you would like, well, let's make it dating. Why not? Probably some of you still date, I guess. So there could be 14 facets of your significant other, like do they blonde or brunette or redhead, or are they do they have muscles? Are they rich? And those would be the 14 facets, right? And then based on all those characteristics, you would say whether or not you want to date them. You'd swipe left or right. And so that's a typical classic binary classification problem. Do I date this person or not date this person based on 14 characteristics? And that's well known in machine learning or AI. It's easy to make AWS do it. And so I could turn my problem, which is a sequence problem, into a binary classification by cheating. And basically I would take every 15 throws, I would give it that data. Now in real life, all this information is somewhat, a lot of this, well, most of this information misleading. All you really have to do is pay attention to these two throws, right? And then the 13 and 14 to figure out how to pick 15, right? But that's okay. It's okay if I give the machine misleading information. Somehow the machine will think, oh, I got to pay attention to all 14 of these, even though you don't. You only has to really pay attention to these two, 13 and 14. I didn't tell it that. So I transformed the sequence problem into a binary classification problem by chopping. It's called like a corner turn, I guess, to like a pivot table. I may have used that. No, I don't think I did by manual. That's also in the spreadsheet. So this is what I'm going to use to feed AWS to see if it can guess what's going on here. So I probably confused a few people in the audience what I'm doing with this spreadsheet, but are there any questions?
So are you saying you're switching from the neural network? I don't want to say method, but like you're switching from neural networks to classification as the algorithm, I guess.
Yeah, but it probably does, because actually I'm going to use AWS SageMaker, so that we'll use neural networks to figure it out. It's just not using a recurrent neural network. That's a special type of neural network to do predictions in a sequence. But it is
okay.
so recurrent. The keyword is recurrent neural network. So I'm turning the problem from a sequence problem into a classification problem.
I see. Okay.
Does that make sense, Dr.
For this one here, you did 15 flips 10,000 times, or what's the?
Oh, so where did this spreadsheet come from?
Well, no, I mean, just this. I'm looking at this sort of chart or matrix. Like, so you did 15 flips, but I'm confused which way we're reading this. So
Right,
is
so
a row a flip, or is that an instance, or?
Right. So reading right to left. So you remember the 10,000 flips?
Yes. Yep.
Okay, great. So flip 1 through 15, reading right to left.
Mm-hmm.
Flips 16 through 30, reading
Okay.
right to left.
Gotcha.
But 31 to 45 and blah, blah, blah.
But was this just take your 10,000 and broken up like this, or was this actually done in chunks of 15?
No, the former. Yeah, the former. So I took my original 10,000 lines and I chopped it into
Okay, gotcha.
pieces of 15.
Gotcha. Okay.
And just
So we're just looking at the same data, just presented differently.
yes,
Okay.
same data presented differently. And by the way, every time I fiddle with the spreadsheet, the data changes because all the random numbers generate. So if I go back and look at that spreadsheet, it's not going to look like this. It looks, red and green, but
Right.
very Christmassy, but not like
Yeah.
Okay. So we were presented with the closed form solution to predicting the streak, right?
Yeah, predicting the average streak, which is on the average how many you're going to get in a row.
Okay.
It doesn't have too much to do with this exercise, the big picture. In some ways, I just wanted to do that calculation to prove to myself I could still do middle school math.
That's okay. So I just wanted to know, like, although it wasn't a linear, it was a non-linear. Actually, was it? Yeah, it should be it didn't seem like a linear solution. So.
Well, it's a geometric series.
Oh, okay. Or the formula, yeah, the first one wasn't linear. So can machine learning in that sense actually like predict non-linear models, or is it purely?
Oh yeah, no, that's the whole point of, especially neural networks. Yes,
Okay.
how does this? So the layers, the number. So I can remember I can't remember the word. It's like
Hidden layers.
I want to say Geotron. That's in it. Geodon is invented in the 60s. So in one neural network, one neuron, right? Simulated in computer. Somebody go look this up in maybe it's like a henodon or geodon. I forget what the word is, but that's just one neuron, right? They invented that in the 60s. Hey, we can make computers simulate brains, and here's a way to do like a neuron. So like so you can have one layer of those. And if you do that, one layer, so neurons, if you think of like neurons and just as like connected in series, I guess you think of, you can only do like linear calculations. So, but if you have layered neurons where they're all connected to each other and they all do weight calculations at each level, then you can have very nonlinear results. So like when you do, the classic example is they'll do like handwriting recognition or maybe like speech recognition. It'll be a neural network, but it'll have numerous layers and it can do very nonlinear results, boundary, and so on and so forth. So, but it has multiple layers.
Okay. So my other question is, okay, so does machine learning predict like give you like their prediction of like an estimation of what the actual model is, or do they just give you like the accuracy for the average streak?
Right. So I'll get to the example a little bit, but basically it'll do like, and when Dante said, we're just touching the surface, it's amazing how much research has been done over decades to come up with all these, I want to say hundreds, it's probably dozens of algorithms.
There's definitely a lot, yeah. Like
and different types of applied to machine learning. And I'm sorry, so what's your question again? Oh, does it tell you which one? Yeah. So I run the data through the AWS and it says, okay, I'm just going to try all the algorithms I know of. So it goes through dozens and dozens of algorithms if you wanted to. And then it pops up, says, well, here, I've tried, 30 different algorithms. And this one had the best results. So it tells you which one it is. And so it's telling you what algorithm it's using to how many layers of neurons or maybe no neurons at all. And so it tells you in general what algorithm it's used, but it doesn't tell you, it's not like if then else classic programming. It's just applying this linear algebra calculation.
Okay. So it won't give you like the closed form solution like you had. It'll give you like, if you run it this many times, you'll just get this number with a 97% accuracy.
Right. Like it goes through all this very sophisticated linear algebra to come up with this nonlinear solution. And it tells you, I use this really sophisticated algorithm invented in 2009, and that had the best result. But it doesn't give you like a closed form. So I use this algorithm, and
right.
That's what I'll tell you.
Dennis, there's a question: do we think maybe this is how we predict the weather?
Oh yeah, definitely. They use what they call them. Nuts. What's that called? Not wires or snakes. What do they call this? The patterns, the graphs. Oh, it's something like.
I thought it was radar and then predictions based off of same time.
Oh yeah. No, it's radar and pressure and temperature, and they use all these facets, but then they
I recall it's like PDEs for weather.
Yeah, I can't remember the name of the algorithm. It has something to do with like snakes or worms, but it has to do with all these. There's straws. It has all to do with these,
straws.
Yeah, I can't remember the graph, but it basically tells you, if the tornado or whatever, or the hurricane could go this way, and if it does, this is what happens if it goes this way. So it's all probability, and simulation and what ifs kind of thing, and it does a search, like a binary type search, but at each point. But yeah, I mean, it's much infinitely more sophisticated than what I'm explaining here, but it's kind of like, this is the alphabet, and then they're doing calculus. They're doing the works of Shakespeare. Yeah.
I'm sure it can be used to aid prediction of weather. Because I know, like, before the introduction of all this like data science stuff, they had their own methods. But now with all this new data science stuff, it would assist with it, I would say.
Oh yeah, it's all machine learning and artificial.
Oh yeah, see, I thought it was just like Doppler, and then this time last year it was hot.
Yeah,
So
well, the
gonna be hot.
Doppler, the Doppler and everything gives you, the facets, right? The 14 things here, right? And then based on that,
Gotcha. Okay.
it does simulations, say, well, this could happen, this could happen, this could happen, and the likelihood is this, right? And so on and so forth. And
the funny thing about that, like, and I feel terrible. This is but it wasn't that long ago when I finally realized that when you hear that there's a percentage of rain, that it's not a chance, it's coverage, which I always thought was the weirdest thing.
coverage.
So when they
What are
say
you
like,
talking
oh, it's
about,
a
Dante?
a
I don't
20%
understand.
a 20% chance of rain isn't they shouldn't use the word chance. They're actually talking about for where you live, there will be 20% coverage of rain.
Oh,
It's not
really?
probability.
Yeah, they're related. I mean, I think my understanding of it is when they give you a percent chance of rain, it's the aggregate of it's like a probability density. So every hour there's a percent chance. So like I have an app called Dark Sky, and it'll tell you what's the percent for each hour. And so like there'll be an 80% chance of rain for the day. Yet if you look at each hour, it's like, 15%. And they go, shouldn't it be 15? Well, no, because it's you might get rain here during this hour, you might get rain that during. So if you add up the whole day, you could be more than 50%, even though for each hour it could be less than 15%. So I think if you think about it, that's the same number. If you're talking about coverage of an area,
Yeah.
probability, it should be, it's just like the example I gave you where you're calculating. That's a perfect example. You're calculating the area by throwing those darts.
Right.
The probability of hitting that area is the same thing as calculating the whole area. So
Mind blown.
yeah. But anyway, it's pretty neat. All this stuff. There's a whole. I mean, that people are. If you had another career, you could spend the next 8 years going through getting your undergrad degree and your PhD and be a machine learning expert. So, or you can spend an hour and a half at this talk, I guess. It's the same thing. Okay, so let's see. I think we're almost at the demo. Here's some things I recommend. Santa Monica College for under $200. You can go take Vicky Sino's class. It's really good. You'll learn about AWS machine learning and other things here. Udacity has, I'm sure they overcharge in many ways, but their PyTorch class is free, and you'll learn a lot from that class, more than you would watching a YouTube video about this stuff, but those are good too. One thing I recommend is privacy.com. Hopefully everybody knows about that. Are you familiar with privacy.com, Dante? You'll be my guinea pig.
Is it a VPN solution?
No, it's a good guess though. Good guess. So this is credit card protection. So perfect example is AWS. So if you get on AWS, you can use your email, and you can accidentally get a ton of charges, right? Even though for the first year, their services, just about all their services are free, or at least there's a subset, not all, but subset of services where it's free, but it's only for that first year. It's called the free tier or something like that. And after the first year, some of it still stays free, but a lot of it stops being free. But you can still violate it and end up with charges even when you think you're using the free tier. Because you use it too much in a month or
Oh
whatever.
yeah, that happened to me. Like $200. I accidentally left on a like
Yeah.
a 24 core, 32 RAM VM for a
So if
couple
you're
of
not,
days.
if you're not worried about them chasing you down, I mean, first of all, you can say, I'm sorry, I was a student. Please give me a chance. And they'll say, okay, and then they won't charge you. That's just,
Oh, do they do
or-
like you can set up multiple virtual credit cards?
right. So
Okay,
privacy,
yeah,
that's
yeah.
what privacy.com is.
Yep.
It's virtual credit cards.
Yeah,
So
this
you
looks
get
great.
put an account on there, you put money on there. A lot of people use it for everything. If they never buy anything on the web using their own credit card, they use privacy.com. And you can put in a certain amount. I can put like a $50 limit, it can last forever, but it probably can put a time limit on. You can give it to your kid. And it's a virtual credit card. You can use it until it runs out. So you can put a virtual credit card in AWS, and then they still might try to come after you, but you can say, I'm sorry, I never heard of Dennis Kane.
And is this is there a monthly fee associated with this, or?
No, it's free. Oh, if you want the fancy, if you want to use like a lot of them, I guess there is a fee. But for typical you and me use, it's free. It's great. So if you use this link, J6XXK, I'll get $5 if you've never joined privacy.com before. I should try joining them multiple times and
So
see if I can get
Dennis,
myself.
what is this? Is this something you pay ahead of, like it's a
Yeah,
virtual
so
credit?
you're right. Yeah, so you put some money
Mhm.
at privacy.com
Yeah,
for free, like say $20,
uh-huh.
and then they'll give you a credit card number. It'll work just like a Visa or MasterCard. I think it's Visa.
But
And
there's no traceability? Is that what you're saying?
well, they can't, it's protected. So let's say you put that number out there,
Mhm.
right? And then somebody attempts to use it.
Mm.
The worst they could do is get to the $20 limit and then
Oh.
it's done.
Oh,
You
okay.
won't get it. Now, you're protected from credit card abuse anyway by federal law, right?
Mm-hmm.
But
Yeah.
this is like even more protection because it just won't work.
Yeah, I think the other use case that, because now that you mentioned that, the name wasn't familiar, but now I remember seeing YouTube videos where one use case was that like let's say there was fraud on one of the cards. Normally, you would have to get a new card issued by your bank, and then you need to go to like the 100 places that is using that card to redo new information to say, hey, here's my new card. Where this way you have the parent card, and if that got swapped out, it wouldn't matter because it would automatically relink all your other virtual cards. So if there was an issue, either one, you wouldn't even have to replace your new card. But let's just say that for whatever reason it was on your actual primary bank card, you could replace that, but all your virtual cards would just auto sync to that, so you wouldn't have to go back. So let's just say you could create a virtual card for your phone bill or your whatever, a virtual card for everything that you use that you pay for. And if there was ever an issue, like Dennis was saying, one, you could set limits so that if someone were to ever get that data, all they could do is max out that one virtual card. If there's like $100 on it or whatever, if it's reoccurring, maybe that's all that they got. But like I said before, the convenience that I like, because I actually now that I'm thinking about this, is I have heard of it. It was the fact that I've had in the past where I've had an issue with a card and I got to get a new one mailed to me. So one, in the meantime, I can't really buy anything. But then when I get it, I got to go to like 12 different places. I got to go to, like utilities and, Netflix and all these other places to update my card because that's what's on file with them. And it's just a pain. Or you forget something and then realize now some service stopped because you forgot to update your new card info. So it's a really cool idea, actually.
Yeah, it's amazing and it's free, and take a picture of the screen and use a little code.
Or I was gonna say if you could copy and paste that into the chat, because
yeah,
I'll probably
I don't know if
sign
it.
up.
I mean, I've never used it. I've never gotten $5 and never told anybody about it, so I don't know. Hopefully, somebody. Maybe I'll get my son to do it and see if he can get me $5. I don't know. Maybe you can only do it once. But anyway, it's worth a try. So I recommend that. That's where you. Oh, somebody's got to leave. Oh, maybe this is a good time. Somebody had an announcement. Maybe we.
Panda. Yeah, do you want to do your?
Yeah, Panda has an announcement.
Oh, thank you for sharing the floor here. I cannot share the screen.
Oh, I have to release it, I think. Or do I? Oh, stop share. There, now you can share the screen.
Alrighty, thank you very much.
Uh-huh.
All right, you guys can see my screen?
CyberMed Summit.
Super. So I'm Panda, for those of you who don't know me. I do application security by day. And one of the other things that I do is I help out with CyberMed Summit. This is a nonprofit organization, and we host events to talk about and demonstrate the intersection between cybersecurity and patient safety. This particular image here is over at the University of Arizona Medical School, and it's in their medical simulation lab. And what we do is we bring in healthcare providers into the lab, and then we ask them to treat patients. And what they don't know is one or more of the devices is hacked. And so we're able to demonstrate what it's like to try and provide care in such a situation. To nobody's surprise here, I'm sure all you guys can guess, is it's not very pretty, and oftentimes patients might die. So we have a free webinar coming up January 20th, Digital Disease, the Patient Safety Threat of Ransomware. This is going to be 11 to 12:30 Eastern Time. The registration link is on the website. We have some pretty awesome speakers that will be available also for a Q&A after the presentation. John Rigby, who's the Senior Advisor for Cybersecurity and Risk for the American Hospital Association, Dr. Natalie Sullivan, who is a practicing physician. She'll be sharing some of her experiences of being a doctor during a ransomware incident, and Dr. Arcady, I can't pronounce his last name, apologies to him. So I'll just say Dr. Arcady, assistant professor at GW in the computer science department. So hope you guys can join us. If you have any questions, feel free to reach out to me. I'll also drop an email in here. So if you guys have questions later on, you can reach out. And I've already dropped the link for our website here. Questions? All righty, thank you very much. And I return you to your regularly scheduled program.
Awesome. Thanks, Panda.
Let me see if I can zoom through this demo. Maybe if I hit this button. Oh, you know what? I have to hit that button. And then I have to find my AWS account. And where do I want to go? I don't think it shows my account number anywhere. Nothing really. Nope.
Yeah, I don't see your account number. I just
That's-
know you're in North Virginia. And it has your name, Dennis ML, but
Yeah, that should be harmless.
yeah.
So so this is not the main. Let's go to main control panel. So if you log on AWS and you get an account and you give it the virtual credit card and become very mindful, then this is the AWS management console. You can also access through a command line interface, but this is how typically everyone starts out. And so it throws up here recently used services and has them all categorized and so forth. But the main machine learning service is called Sagemaker. Got a little, I guess that's a digital brain thing. So you can click on that, or you can type up here Sagemaker. Probably if you type machine learning, it would find it too. So here's Sagemaker Studio, and here's Sagemaker. Yeah, so I click on here, click on Studio. That's like a development platform for machine learning. And so it brings you to a setup page. And if you click on Studio, I forget what our Studio is. Canvas is their new graphical machine learning environment where it's like no code. You just plug and play widgets to do a machine learning experiment. but the one I'm familiar with is Studio. I should try Canvas. But so if you click on Studio, you'll get a screen related to SageMaker Studio, unless I'm already there. I think I'm already there. So then you can click on Launch App here, and then it's see, what is it? I'm trying to see if it already, if it built a domain, then it's probably skipping. Okay, so now it's, yeah, I didn't, it already went through what I want to show you is if you, there's one button you click on when you first get in, and it says it's building something. I forget what it's building, some environment. So right away, nothing happens. So you might start clicking random things because you won't notice at the top of the screen, it says, please wait for your environment to be built. So of course, I always ignore dialog boxes. It was actually just a message at the top of the screen, like a cron roll or something. So I started clicking things and just wait. You just try to read the whole, when you click on something in AWS, wait, because it has to set up your cloud environment and make sure you read all the little messages. But anyway, so it throws you into this. This is Studio. So this is their nice platform. It's Python based, right? You can set up a Python Jupyter notebook in here, and you can get Linux. There's, I think it's like a Linux-like underlying platform. And I don't want to take you through all these icons. Just go watch a YouTube video and they'll tell you what all this means. But you can basically set up an experiment. So the thing to do is click on Autopilot, right? Autopilot does this experiment for you automatically. And so you click on that, and then you tell it various things. What's your experiment name? Your S3 bucket. So S3 is like AWS's Google Drive, kind of a little bit. I mean, it's simply that. It's a storage, cloud storage. I forget what S3 stands for. It's something like simple something or other, but simple storage something. But that's where you put files, right? So so in addition to this, you have to upload that that spreadsheet. So if I took the spreadsheet for my bias coin flip, and I go to the SageMaker feed, right? And then I go to File, Download. Should be, there it is. And I'll say like a CSV, which is comma separated values. So it's not a spreadsheet, it's a text file where all the data is separated by commas, right? So it's like a universal data version. So it kind of looks like a spreadsheet, but it's just textual with numbers separated by commas. So that's how I would download this. And then I would upload it to AWS on this. That's payment methods, very important. So this is probably S3, right? Yeah, so this is like an S3 sheet. You know, you can go here directly, or you just type S3 here. Oh, there it is. Okay, so things happen so fast sometimes. So, you know, it's the drives are referred to as buckets, right? So SageMaker, when I fired up SageMaker, it automatically made some buckets. So I could throw that CSV file into any one. I think I threw it into here. Let's see, maybe not. Threw in the other one. There it is. So it says bias coin flip SageMaker feed 80/20. So I created an 80/20, 80% bias version of the spreadsheet with the 15 columns, or is it 16? I think it's 15. It's 15 columns. And I uploaded that file to here, right? So now SageMaker can find it. So I told it in this screen, yeah, here. So I told it to, you know, I've done this already. So I told it to go look in that bucket, go look for that file, go grab it, go learn what to do with it. It even, you have to tell it like what column, somewhere in here, you tell it what column is going to be your feature column. That's the flip 15. So you're telling it, here, guess this column. So it takes that giant spreadsheet of whatever 10,000 divided by 15 is, it chops it into 2 or 3 actually. It takes a portion of it and it learns from that, right? So it's machine learning. So it's checking all these umpty scump algorithms, and it learns from a portion of your spreadsheet, and then it takes it and it validates it by doing various tests. And I guess I could try to set up, you give your name, experiment name, let's call it Bob, just for the heck of it. And your bucket, I don't know which bucket it was. Maybe it's this one. I'd go back and look. I think it's this one. Well, it's kind of stuck. Well, let's see if it's that one. Oh, look at all. Oh, see, it created a model, so put all these files in there because I ran this in like 2 hours ago. So it's creating all this stuff. I think what I call it. See all the SB Wasp. Oh yeah, I created a project called SB Wasp, whatever. But there it is. So I told it that's my file. So it's looking inside the file. Oh, see now, so it already looked in the file and it knows there's 5 columns. So it says, what's your target? My target is flip 15. So look at the first 14 flips and guess the 15. I don't know. Somewhere here it asked me, do I run? Oh, machine learning problem type. It's a binary classification. See right here, it doesn't say sequence. So that's why I didn't pick that. So binary classification knows how to do that. Objective metric accuracy. So now it'll tell me, oh, here's how accurate we were. And whether or not, do you want to run a complete experiment? So if I say yes, it goes through all of those algorithms, finds the best one. Otherwise, it just does a partial, and then I pick which algorithm I liked, and so forth. So I've done this already, yes, because if I hit create experiment, it just goes on forever. And I'm hoping some of this, well, let's see, it's not that. Is it here? No, it's just a new tab. I thought I have an example of the results. Let's see that it was running. Now let's get rid of privacy. That's my billing. We already talked about that. Hover account. Well, that's funny. I thought I left a tab open. Thought I left a tab open. Oh, maybe I accidentally closed it when I did that. Oh, maybe this is it. Oh, is that it? Oh, here it is. I think it finished. And open. Yeah, so, oh, I see. So it gives you 2 choices. So it ran forever. Trust me, it runs for hours. And you can use the data exploration notebook. So these are Jupyter notebooks. So it builds these notebooks for you. I didn't write this. And it went through the data and it gave a warning. It says 25% of the rows are found to be duplicates, which doesn't surprise me because I used an 80-20 on this one. So a lot of the times it reduces the variability of how the rows look in that spreadsheet because it's very likely you're going to get 3 or more in a row. So it's warning you, hey, you gave me a 10, whatever 10,000 divided by 15 is a bunch of rows of data, but a quarter of them were the same. So why'd you do that? So it's warning you. That's nice. And then it does various analysis on the data. It's a heat map of the core. This is like the correlation of the various flips. And you can see that the correlation increases as you get up here because all that really matters are flip 13 and 14, right? As you know, because the other flips don't matter so much. And it's so this is just analysis of the data. This is not actually any thing special about that. But here's the candidates for machine learning, and then it should tell you the score. I forget where that is, but I do have it in my document. Let's see if but it generated this whole Jupyter notebooks. This is all Python code and some JSON. You know what that is? That you can use to run. So I could figure out which one of these algorithms or machine learning models was the best, and I could run that against new data if I wanted. And so where is the summary table? I forget. I'll just look at my document. So one of the data tables it gives you is down here. Here it is. So it gives you a table that tells you how well it did. So this row here, right here, is this validation object. Here is it tells you how often it got correct information. And I think this was for the for the 80/20 when I ran this before. So it got this model, this one model got it right 70% of the time. So just from giving it those examples, it figured out, it went through many different machine learning models, and it came up with one that was right about 70% of the time. And if you remember, looking back here, I think that was a 0.8. Let me see. Yeah, so using Monte Carlo method and cheating, because I know the algorithm, right? I know that, the third time in a row is likely 80% of the time. If you do all the analysis, on the average, I got a 71.71% correct. And through my closed formula, which is wrong, it thinks it should be 65. So I get 71.71%. And in my using machine learning, it got just under 70%, correct 70% of the time, with the 80/20 bias. So it matched, interestingly, it's pretty close to the Monte Carlo result I had in the spreadsheet of what I think it should get correct. And it's 5% more than what that calculation I did, which apparently is incorrect, so I'll have to go redo that calculation. So most importantly, what I need to do now is try to shut down everything I can find in my on my AWS account here, so I don't incur any charges. So I need to go do that. So I think it's about all I wanted to show you. I guess the one takeaway, other than take the class at SMC if you have time, is that AWS. I didn't write any Fortran, or I'm sorry, Fortran. I didn't write any Python code at all. It generated all this Jupyter notebook and all this for me, and this whole narrative in a Jupyter notebook. All I did here was I filled out a dialog box with describing the experiment I wanted to do, and then I uploaded the CSV file, and then it just took it from there. So, and it did some amazingly sophisticated stuff. But it took a couple hours, but it picked the best algorithm. So that's about it. So any questions?
So was the idea of using this just sort of like to reiterate or confirm what you had previously done in the spreadsheet?
No, the whole point of doing this was to see if machine learning could actually do as well as I could, and I know I didn't tell it anything about
Right.
biases. I didn't tell it anything. I just told it, here's a CSV with a bunch of misleading information, right? Because all that matters is toss 13 and 14 of each row, right? It's all you really have to pay attention to get the best score you can. But I gave it all this information. I said, hey, go figure out how to guess in the best way. And it did, and it came out with an answer, you know, when it applied, because what it does is it learns from a portion of the data, and then it tests itself against the rest of the data. And when it tested itself, it got 69.8% correct. And according to my Monte Carlo, that's about right. I get like 71% or something.
So Dennis, I'm going to put you on the spot. Okay, you're using SageMaker, right? AWS. It looks very cool. So in the future, again, would you rather use Monte Carlo simulation, or would you use
Right,
the-
so they're not competing. I didn't really use a Monte Carlo to, let me think about that. What's the right answer? Monte Carlo is great for, well, I'm sure, let me rephrase that. So the way I use the Monte Carlo is to verify my math and to create the data for SageMaker and to simulate a coin toss. I didn't actually use a Monte Carlo solution to do AI on my own. So it's not so much one or the other, it's both. So like, you know, think about maybe a chemistry lab. The Monte Carlo simulation was more like me gathering the chemicals and the beakers and the Bunsen burner, and then the actual putting it all together would be like the machine learning aspect of it. So it was complementary how I use it. I suppose one could build, if somebody was infinitely smarter than me, you could use spreadsheets or better yet, a Monte Carlo based approach to create a machine learning model and so forth. But
yeah,
but
that was just a question because I worked in a modeling simulation group before, and most of the engineers were using, I mean, I hear Monte Carlo simulation all the time, right? I don't know if they were using something else as well. So I'm just asking. Of course, this is like over at least 7 years ago or 8 years ago. So, okay. All right. Any other questions for anybody still online?
Yeah, which of these is going to help us win at roulette? So I can go to Vegas.
Wow, Dante.
And I'm not even a gambling man, but now I'm like, roulette, blackjack. I'm sure there's got to be a way to.
Really?
oh, I'm
Especially
sure
with
there's-
roulette, because that's like whole, red, black, and
Well, I
even
saw
odd
Mike
numbers.
responded.
I mean, I know I'm not the first person to think of this, but I'm just surprised there's not like.
Well, they have rules. They have rules to prevent you from bringing in a computer.
I don't know. I
probably.
get those Google or Facebook glasses, and I'm sure I can get
Yeah,
Alexa on one of
Dante's
them.
gonna wear that to a
I want to make
casino, right?
I'll write a Python script to count numbers in my glasses.
Yeah, but with AWS's billing, it might cost you more than you might win.
I'll go all in, whatever it takes.
Wow.
Interesting.
Yeah, I hope I give you at least a flavor of. I mean, if you want to learn about machine learning, yeah, you either take. Well, I mean, read a good book. That's one way. Or Vicky, the SMC class or the Udacity class, or there's the AWS Educate. They have a machine learning class, but I forgot to mention the best part about the SMC class. Gosh, AWS now has something called AWS Academy, which is it's like you use Canvas, if you know what that is, and structure Canvas. So you take class at SMC, you get a sandbox. You don't have to provide a credit card. So Dante, you would not have to worry. You're protected, and you don't provide a credit card, and you get AWS sandbox, and you get to use. There is a credit limit, but you don't see it. It's not tied to your credit card, and you still need to shut things off. It's just that they won't come after you if you don't shut things off. So you're better protected in that. So that's another reason to take the Santa Monica class.
So Dennis, AY has a question. She posted there. How does Sage compare to TensorFlow?
Oh, okay. So SageMaker, it's as you see, it's all, especially autopilot, it's automated. It's whereas TensorFlow, I believe, it's like PyTorch. It's where it's a library of algorithms that, so you have to know how to program in Python, and you have to kind of know what the algorithms do and represent. You have to have a lot more capability. Where if you use SageMaker Autopilot,
Mm-hmm.
it does a lot of the work for you. Like I said, you just provide the data, and you have to know kind of what your problem is, right? You have to know that it's, in this case, it's a binary classification problem with 14 facets and one target. And I had to know what that gibberish I just said, what that means, and then I have to be able to build a CSV, and then I'm done. I didn't have to write any Python code, bring in libraries, manipulate any of that. So,
So Dennis, in your first sheet, you had sort of the building blocks of machine learning versus AI. So where are we at in those three sort of, you had like the sub machine learning, then AI. Where would you then take this, or where would the AI come in from what you've just done here?
okay. So where were we on this?
Slide 5, yeah.
Yeah, so
we're in the middle, I guess.
Right. So we actually were kind of both in here, because what happened was when I fired up SageMaker, it probably
Is doing some deep learning of
it might be doing some deep learning too to get the right algorithm to because it went through, like I said, dozens of algorithms, and to train itself, and which is, like taking a chainsaw to put butter on a piece of bread, right? Because the example I gave it, this coin toss thing, is an extremely simple problem, right? That we know as a human, since we know the algorithm, we could cheat and get the answer right away. I was just trying to see if, we could use very sophisticated machine learning to get this pretty simple answer, right? It's not trying to do something complicated, like, figure out the stock market, or whatever LeBron's question was.
So then how would we then implement what you like? What would be an example, I guess, of
okay, so
taking what you just did and then implement it somehow into artificial intelligence?
Right. So the value, hopefully, that people got out of this talk is there is this thing called AWS SageMaker, through which you can build sophisticated machine learning models to do all sorts of, like, you could work for Netflix and predict what show you want in your feed, or you could work for some company and when do you sell apples, what time of year. I mean, it seems like a simple, I can't think of a good business example. I guess the one machine learning, I was talking to a guy for his job, which sounded pretty boring, but he would use machine learning to examine cans. I think it was like canned fruit or food coming down a conveyor belt, and recognize which ones were so dented that they wouldn't sell, and then they'd be knocked off the conveyor belt. And so he was writing machine learning, artificial intelligence software to do that. And they probably use business models saying, well, if it's a little bit dented, people will still buy it and they sell. Where if it's a lot dented, in which way they won't buy it, and which seems kind of, a lot of money to spend on just that, but that's what he did for a living. So at least in this contracting, it was like a contracting.
So the artificial intelligence takes what has been done in machine learning, but the artificial intelligence doesn't, what's the word? Doesn't I don't want to say understand, but doesn't augment, or does it? It doesn't change anything that it's learned. It just uses.
Yeah. So this chart is just a Venn diagram of what these terms mean. And so all machine learning is artificial intelligence. all deep learning is machine learning. And it's also
Right.
so they contain each other. So when you go through this process of building a machine learning or artificial intelligence model, if you want to call it that, using SageMaker, so that thing I built really knows very well how to deal with coin tosses that have a bias of 70-30 or 80-20 in the way that I described. But here's a cool, here's something that, could you use it for code breaking? Could you use it for like a whole, so suppose you had a sequence, something much more complicated than just, but if you get the two tosses the same, then pick the third one based on this bias. You could have a whole sequence of like 100. What if I get, these sequence for 100 tosses? Here's what the 101st should be, right? You could have all sorts of like more complicated rules. You could have a sinusoidal probability, right, of heads and tails.
Mm-hmm.
And could it recognize that? Could it what's interesting is, like, to me, I learned this a few months ago. Do you know how, let me see if I remember it. Do you know how they teach machine learning models and algorithms how to speak a language, like how to understand different languages, like all the grammar and the analytical syntax, all the grammar, everything. Do you know how they teach? So they build a model. How does the model teach itself?
Wow.
So
It's all autonomous too.
right, so it needs a data set.
Yeah, it has a data set.
But I mean, but the data set would be the answer, right? I mean, the data set would be whatever is in the data
English.
set.
It's in English, but do you know how qualitatively to describe how it
Yeah.
teaches itself English or Spanish or name some other obscure
Watches
language?
YouTube in English, or whatever native language it picks.
Right. So here's what it does is you feed it volumes and volumes and volumes examples of English or
Right.
whatever language you're trying to teach it. But you cut out some of the words. Right?
Oh, so it then has to figure out.
And then it figures out what's missing. And then it comes up with a prediction of the word, like the dog chases and then there's a blank, right? And if it comes up with cat and then it was cat, then it gives itself a little score, right? But if it came up with the dog chases the rhinoceros, it's wrong. And so it gives itself a negative score. So you let it churn on that for months and months and months. I think Google, is it Google? No, I think it's this Facebook has this program. I forgot what it was called. I read about this a few months. I read about all this stuff. I forget what. But I think Facebook has the biggest font. It's using like a football field full of supercomputers, and they're all reading Shakespeare. It's like the monkeys typing
right.
randomly, and they come up with Shakespearean plays and stuff. But anyway, so they're reading all these documents in various languages, and with very randomly words missing, right? And then the models try to predict what word is missing. If they get it right, then they score it appropriately, and then they train all the parallel neural networks accordingly, and then eventually, after months and months and months, they come up with some thing, machine learning model that understands English, because it went, it's like if you learned how to read by reading all these texts with missing words in them, and then you had to fill in all the missing words. So that's, and then it can do it autonomously. That's the whole point with machine learning, right? You don't have to sit there and tell the computer when it got something right, when it got it wrong. You just feed it, terabytes or petabytes or whatever comes next of data, and then it eventually, and then at some point you come up with some Frankenstein monster of a program that understands English. Pretty wild.
Yeah.
Any other questions? Well, I hope you found this somewhat valuable. maybe more so than the classic example of like handwriting recognition that they have that you see all that example all the time in books where they guess the numbers 1 through 9 or whatever. Try to recognize the numbers 0
Yeah,
through
I think we had a presentation before of how to recognize the
Oh yeah.
whatchamacallit.
Yeah, I remember that one. Those bright guy, smart young student.
Yeah. Yeah. So
This
yeah,
is just
and I
a different twist. This is more
it's
like
a
a
different
gambling.
right.
It's a gambling version with some Monte Carlo.
Yeah, Bill Pedersen, he
Yeah, that
did
was
the
fun.
talk, right?
Yeah. So it's a little bit different approach. Hopefully you found it somewhat valuable.
I would be interested. It would be kind of cool, maybe if there could be a real time like UI where almost like a game, but you're not really participating. You're just watching. Where, let's just say on the right hand side of the screen, it does 2 flips, and then on the left hand side of the screen, it tries to guess which the next would be. That would be kind of cool to try and sort of watch.
Yeah, especially if you made the sequence more complicated than just, whether or not it gets the same as the last 2, whether there's a whole pattern. Well, have you ever played chess against a computer?
Yeah.
Have you ever set up 2 computers to play against each other?
No.
That's kind of fun. And you're just the middleman, and the 2 computers are playing.
Really? Oh
Yeah.
wow. I've never seen that before, Dennis.
Yeah.
2 computers are playing with each
Well,
other.
I mean, that's
so-
how the Go program
Yeah,
Oh.
it played itself like a
Played
billion
itself.
times or
Oh,
something
okay.
crazy.
for
Uh-huh.
like 2 million times or whatever in 3 hours or I forget. Go read,
Mhm.
go read an article about AlphaGo and it'll just blow you
Uh,
away. The movie's entertaining, but it's not as informative as a lot of articles about it.
mm,
But the movie's it's good. I recommend it.
okay.
Oh, how does this rate to cybersecurity? I don't know. I mean, like I said, spam filters, right? But I assume, well, I mean, I think of your talks, Dante, where you're doing Hackabox. It'd be fun to have an AI machine
Yeah,
learning.
I wish there was a way. Maybe we can do a collab or something, but I wish that I was smart enough to automate. I know that
Mm.
the company I work for, we do have an AI department, and I know we're always actively, because some of our applications do have a bit of behavioral analytics and attacker analytics and things like that. But I'm always joking with the idea of some sort of automated red team that's going to replace at some point in the
Yeah.
future. I'm sure that a lot of jobs will be automated, and I'm sure that's why I said I feel like we're only scratching the surface in multiple
Well,
figuratively and literally
you
on a
might
lot
want
of
to pay
of this.
attention. You may want to pay attention to that AI team and make sure they're not spending their time trying to write a AI model or machine learning model to replace you.
Yeah, exactly.
And if they are, you might want to, unscrew the light bulb in their
Yeah.
room or, or just,
But I think I think we will eventually get I think it's going to come down to whoever writes the best algorithm, or because we're gonna get to a point where the offense is automated, and we're gonna get to a point where the defense is automated. So at that point, it's just and now it's robots. It's playing chess against each other.
you should walk into their offices carrying a nice hot cup of coffee and, hey, what are you working on? And spill it in their keyboard and.
So, well,
Sorry.
luckily I know that what they're working on isn't. I'm in no threat, but or danger, but I know that at some point all of our time's up when it comes to
Oh yeah.
some of the manual tasks and things that we do. But until then, I get to love to do what I want to do. But
there was a really good talk at B-Sides Las Vegas a couple years ago about using artificial intelligence and trying to use it to predict how to perform a pen test. Essentially, this company that does pen testing for as a business set up a call it like a I'm not even sure exactly what to call it. So it's kind of like their interface to how they run their interpreter scripts or whatever scripts they have, right? And the idea was they gave a list of, so basically after recording a bunch of people doing pen tests and like what things they did in a row and what the results were, they used that to come up with a list of the most likely thing you would do next. And then they basically kept running that through their pen testers to try and come up with an artificial intelligence algorithm to basically choose your own path type of thing. So what ends up happening is later on, after they've done this a bunch of times, they have essentially a UI interface where it gives you a list of things to try first, right? And then based off of what happened, it'll give you another list of things like with the most likely thing on top. So what it ends up allowing you to do is the pen tester is still like reviewing that what's coming back and what's happening, right? But it makes it really, really fast because all of a sudden, like, oh yeah, that is the right thing. We'll do the first thing. Oh yeah, it is the right thing. Oh no, we'll do the second thing.
So Dante, do you still have all those notes? What do you call it? Watermelon? What's the thing that you used to take notes with?
Cherry tree,
Watermelon?
right?
Yeah, cherry
No,
tree.
cherry tree.
Man,
Nothing to
you
do
know
with
some fruit.
watermelon.
Yeah.
I was glad.
Thank you.
I don't know how you got that, Linux girl. But
I
wow.
She knows how I think.
I
Yeah.
didn't even know what he was saying.
Yeah, it was
cherry
some fruit.
tree.
Yeah, so you take all those cherry tree files
Oh
Yeah.
yeah.
and give them to Char, and or we'll run them through Sagemaker, and boom, you can retire. You can resign from head of this group, and we'll just run this Sagemaker model to do
Because
all
I've
your
scripted some stuff, because there is, I think every pen tester, will always have their go-to things that they try, and whether it's a good habit or bad habit, and I'm no different. So I've scripted some stuff to where if I know I'm going to run A, B, C, D, and E, I'm pretty much every time, regardless. I've written a Python script to essentially kick off these things in a row, and then it runs and makes a output to text and stuff. But there's no logic to that. I'm just simply automating what I would do. But I know that I know that at least we have where it's a lot smarter than that, some if then else stuff, actual logic, as opposed to just automating something. But
right. So the if then else is they call classic programming in machine learning, but what Char described is where you just take the whole pile of data and you throw it at artificial intelligence or machine learning, and it comes out with its own recommendations based upon what you've done in the past and whether or not it's been successful. So.
Awesome stuff.
Yeah, it's really impressive that these young guys are doing all this stuff at various universities, and it's mind-blowing how much research has been put into this.
Dennis, AY also put some stuff in the chat about a professor give a presentation how blue teams use AI. That's like a behavior. I mean, I
Yeah,
think
that's a
I've
behavior.
seen some vendors, they always reach out to us saying we have machine learning AI where it's behavior based, right?
Yeah,
Rather than
UBA, ABA. That's at least we have that as
and
well. I'm sure everybody has to
right,
have some form of that. Otherwise, how are you going to stay competitive? But yeah,
right.
but it's all off of data and and it's for us. It's our Insight IDR sim, and it's just basically getting logs from everything and then making patterns and then determining. Bob doesn't usually log in from Jamaica. He's not on vacation, so there's a flag.
Yeah,
but,
reading logs.
Yeah, I would think that the blue team. I don't want to. I'm speculating, but it seems like that would be an easier place to start than the offensive side. I don't know. I could be wrong, but it just seems that there's just so much data to pull in from that. It seems like you would have a better set.
Because I've seen vendors again reach out saying they have all this behavior analytics capability to do better prediction, whatnot. So, but I haven't heard about offensive.
Exactly. Like other than scripting and stuff, but I don't know how.
That's actually starting to enter some of the open source blue team tools. So if you look at like Elastic Seam or Graylog, they're starting to do behavior and analytics.
Oh,
too.
nice. That's great. That's going to really help, I think, keep keep other like I don't want to, I guess proprietary or whatever, like in check, because those are like the key things that they sell themselves on as this is what we do and open source doesn't, and this is our leg up.
Well,
But
the other problem with that is none of the commercial vendors would ever give you like their model, right? What happens is your telemetry gets sent back to their server and they're running your telemetry through their model. And then it alerts you. So basically you never actually get to see like what the actual algorithm or weights or whatever it is.
True.
Yeah. And that's the thing, if you're going for proprietary solutions, right? You pretty much, the companies have more control over. I don't know what's the right word to say it. Versus the well, I don't know if it's open standard, but it's, non-proprietary solutions. So.
Anything else we want to discuss? Because I think that's pretty much it.